So yeah, about the attendance, just make sure you're aware that you have to attend and sign the sign-in sheet every time. The lecture from yesterday is there, but there's also another video, which is a video about the algorithm. That goes with today's lecture. So I'm not going to sit here and watch the video with you. Sorry, it's there. You watch it in your own time. Is that all right? I mean, you can watch it in the classroom here if you want, but it's a nice video. And then there's a link. This is yesterday's. There's a link, and it's to join a code.org section or class. And you'll notice there's a special number there. Well, it's not a number, it's a code. NRWPGP. This is unique to this class. So, I mean, if you went to somebody else's class, they would have a different number. So by following this link, you will get a chance to go to code.org, and you'll be able to sign up for this class and do the activities. Now, the activities is and so you're going to have to put some things there, maybe put a password, etc. And when you register, you will be registered in this class. And so you will have presented to you the course material that you're supposed to do in code.org, which is the Express course. There's an Express course. It's about 20 lessons. Now, you have to do this stuff on Angry Birds, and that it might seem a little bit, anyways, it's still good. You know, it's fun. I went through it. So you've got that to do, code.org. And so what I'm saying today is don't just look at the notes that I've put for today's link. There's some others there from yesterday. And actually in today, I did put that, right? So all of that I put there. All right, so we've got this lecture. You can follow this lecture on the PDF. This is a link to the PDF, but I've got it in a PowerPoint. And the reason why the PowerPoint is different, as you know, is because of the notes. All right, so we're recording this, so you might want to just pay special attention to the notes, because there will be things in the notes that apparently I can't give you, but I think I can show you and talk to you about them. Right, there they are.
We can enter our student email, right?
I'm not sure what you mean. Oh, right. So as your registration for code? Yeah, why not? Yeah, I mean, you don't have to use your Gmail or whatever account that you've got. So we are recording. There's only 13 slides. This won't take too long, I don't think. It's also, I think this algorithm thing is not as challenging a topic as the abstraction. I think abstraction was a little bit harder to sort of work with. Algorithm is pretty straightforward. So I think that you'll find today's lesson is, yeah, kind of nice. And so as this diagram shows, we remember the brain being in 4 different quarters. You know, everybody uses a brain for some kind of graphic illustration. But for us, the graphic illustration of the brain is representing the 4 different components that make up computational thinking. Suppose we use the brain because of the thinking part of that, right? So we've talked about all of these 3 already now. Decomposition, breaking problems down into smaller problems, then solving each of those smaller problems, then we can put that back together in our problem solved. Recognizing patterns. Recognizing patterns is kind of similar to that, because then we can just focus in on the part of the problem which is a pattern, solve that, and then we can repeat it. Abstraction, the idea there, why it shows a cube and a square is because if all you cared about was the 90-degree angles or something like that, you could get that information out of this less. All right, so we don't need all of that information, and so we abstract. Remember, abstracting is applying layers. Every time we apply the layers, we cover something up so that it can't be seen. And so we end up with less description information, and that makes it easier to use, more accessible. So, I mean, the really, really good example from yesterday's lesson, I think, was the one of the guy trying to do the, trying to work out the problem of that little town of Königsberg, how to go to all 4 different districts in the town without crossing any bridge more than once, you know. And we looked at the map, and there's way too much information there. But when he just said, okay, this is District 1, you know, and then had the bridges on there, it was a much easier sort of problem to solve. So now we're going to talk about algorithms. And of course, the symbol that they're using for algorithms, I hope you recognize that. That actually would be like a flow chart. Omar.
There was a question I forgot to ask you yesterday. Is there like a default specific answer for what's the meaning of abstraction?
Of a fraction?
Abstraction. The default answer.
Definition.
Yeah, definition.
No, I don't know. I would just look at a Wikipedia thing, so.
We were asked to explain it.
In a quiz.
It doesn't matter in a quiz or a lecture or.
Yeah, so abstraction is going to be simplifying something complex by focusing only on the points that are applicable to what we're doing. Let's see what Wikipedia says about it. I mean, you know, there's, okay, so I'll move this down here so I can see. Let's see what Wikipedia says about it. Abstraction. I spelled it right. 2,500 results. All right, so the quality of dealing with ideas rather than events. Okay, that's not really helping, is it? Freedom from representational quality. That's not so good. So, I mean, what would it be in problem solving? Abstraction and problem solving. Abstraction is the process of filtering out. So, yeah, be careful with it, right? So it's about ignoring. That's how we've discussed it, right? Ignoring the things that are not sort of important for us. So yeah, there's other, we found out just there is some other people have some other ideas of what abstraction is, like it's an art form or something, you know. Anyways, we're going to use this definition of abstraction, which is filtering out and ignoring all the things that are not pertaining directly to our problem. So that's the one that we're going to use. I hope that helps. Did I answer your question? I hope so. All right, thanks. So we've finished those three. Let's now look at algorithms. And you notice that we do have some notes on here. Here we mention some formats that we use to represent our algorithms. So an algorithm is going to be step by step. It's going to represent a problem and or a solution. So as it says, process set of rules, and we can use these different formats for representing an algorithm. So we could just write some words, plain English. That's how you do your recipe. We could do pseudocode, which is more, how you say, it's more standardized. It's kind of like the structured, we actually used to call it structured English. It's kind of like English, but we have some rules that we use for it. And then we have flowcharts. And flowcharts, some people really like flowcharts. It's a little bit of work. Now, you know, if you wanted to do flowcharts, what I would recommend you do is go along to draw.io on the internet, and you'd find a free cloud-based drawing tool that will draw, that you can use to just click and drag and make nice flowcharts. So that's nice. Plain English. So here's the example we have for plain English. As mentioned, that could be in a, this is typically what you see in a recipe book, in a cookbook, is just plain English. You might also see it in your owner's manual, right? Or your mechanic's manual for, you know, fixing your car or motorcycle, something like that. You would have steps. All right. So you could do that. Actually, often in those steps, you might have some graphics as well. And I think we did mention, did we not mention when we were talking about something else about IKEA? IKEA does algorithms on how to build whatever it is you buy from IKEA, because IKEA, all of the furniture is shipped around the world in what we call flat pack. So it comes in a box, which is really flat, so it doesn't take up much space. So it's cheaper to ship. So, but that means that somebody at the destination has to put it together. And often it should be easy enough that the actual purchaser can put it together. And so they give nice instructions, but the instructions in IKEA, instead of being a bunch of words, there's a bunch of photos, right? Not photos, drawings with numbers on them. So, I mean, I guess that could be another algorithm. All right, so pseudocode, we got a bit of an issue with where the dash is there, but what we're doing in this pseudocode is you'll notice that we're applying some rules to a little statement that, sorry, instructions. These instructions could have been in plain English, but we've applied some rules. So for example, we're declaring here variables, and when we declare them, we actually nominate the type. If you're using Python, you wouldn't need to use the type, but if you're using Java, you would. But this is not a program, right? This is just a pseudocode. So we're using the type so that whoever is going to take this pseudocode and turn it into a program will know what types of variables to use. Now, as I said, if you're using Python, you wouldn't have to worry about that because Python does that for you automatically. All right, so what we've got is we got some steps. This thing happens before this thing. That's the sequence. And then we have a value is calculated. Then another value is calculated, and then an output. What do you think would be the result? You add, so sum up would be 3 plus 5 plus 8. So that's 8 plus 8, right? 16. And then divide by 3. Well, that's a problem, right? Because it's not going to divide evenly by 3. It's going to be what? 5.3333. So the output would have to be a float. And there it is. Yes, we generally do make the average a float. I would say it would be 5.333. You could test that on a calculator if you wanted. Another way of doing a algorithm is we can represent them in flowcharts. And flowcharts are nice because just looking at them, we can see stuff just by the shapes and the colors and stuff like that. So you can tell when you see this, that what you got is an input or an output. All right, actually, all right, so we're separating the inputs and the outputs that way. You can tell by these things here that that's a connector or a start or end, and you can tell that you got some process going on here. And so flowcharts are kind of nice. As I said, you can find flowchart drawing tools free to use. If you have, on the other hand, if you have purchased, for some reason, you purchased Visio, which is an add-on to the Microsoft suite of programs. You could buy it. It doesn't come with your standard packages, but you might have it. And Visio is very good for doing those things too. And, you know, of course.
So, sir, flowcharts are the instructions?
Yes, just like the pseudocode. Flowchart does the same thing as pseudocode, except with pictures instead of words. All right, so what happens in you just asked me about instructions. So yes, our flowchart is instructions because it's an algorithm. So algorithms have instructions in them. They record where our processes are. They talk about programming structures, constructs. There should be an S there. So programming constructs, for example, we can have functions, we can have loops, we can have if then else's. Those things will show up in your flowchart, and they should also show up in your pseudocode. And they should have a starting and an endpoint. I hope you saw that in the slide that I showed you a minute ago. As it says here, so a flowchart or a algorithm of any type is just going to be how we think the logic of that program should be to get it to work. And because it's how we think, we could make a mistake because sometimes we think wrong, right? And so that's a problem that sort of shows up in algorithms. So somebody will write an algorithm and the actual logic is wrong. And so we try to check our algorithms. We can do a desk check on them. We'll look at that later. All right, so they've got a little bit of a note there about constructs and control structures, loops, repetitions. I did mention those things. Start and end point should be, and correctness and efficiency. Efficiency is a big thing as well as correctness. You'll see that when you're doing sorts or searches, but many other things. I mean, in many cases, there's a slow way of doing things and a much faster way of doing things. And of course, when we get one of the reasons why we use a computer is to make it fast. And so you could have, for example, a sorting program, which was very slow. That would be okay as long as you only had a few things to sort. But if you had many, many things to sort, that would be a problem. Okay, so to remember, when you get into your programming class, I don't know when, second year sometime, you'll come in contact with the concept of the big O, the big O. All right, so you don't have to know about the big O now, but I'm just telling you, all right, it'll come up. What that will be about is about efficiency of the program. So this is computer science. I mean, this is computer science. How can we make this program more efficient? And so because of that kind of studies, people have come up with many different ways of doing searching. And there's some things that are much more efficient than others. So the big O, what it does is it will represent, well, if you're going to do this operation, will it be a sort of a linear increase in the number of steps, or will it be an exponential increase in the number of steps, or will it be logarithmic? And so you'll be able to determine those things. So I think you get the idea what a exponential increase in the number of steps would be. That would be really, really bad, right? And yeah, so that happens with some computer programs. I'm not teaching you the big O. I'm just telling you that you will come across it. And the big O is about that concept of efficiency. Right. So as I said, next year, whenever that comes across, whenever you come across that, remember, oh, that's right. I learned about that. I learned that this would be coming. I didn't learn about it, but I learned that this would be coming. Could be next semester. Next semester is kind of like next year, right? Oh, no, you won't be doing that during the summer semester. You can only do, there's only a few courses offered in the summer semester. There wouldn't be any of those second, third year programming courses, I don't think. Maybe, but I don't know. Right, so what do we got here? Basic steps in an algorithm. So if we had an action game, the player could move forward and backward. Then there would be some consequence depending on where they moved, right? So if you moved here, the program would progress in a different way than if you moved there. Low-level programming instructions correspond to basic instructions of CPU. All right, and we got some notes there about an industrial PC. Yeah, all right. Some people need to take computers into dangerous and dirty sort of work environments. And so you can spend a little bit extra and get a laptop, which is an industrial laptop. And, you know, you can, I mean, the advertisements you see for these laptops, they throw them on the ground, you know, they drive their truck over them and stuff like that. So, you know, they have some kind of metal case and they're just a bit stronger than yours, right? And yeah, and so you pay a bit more money. So, I mean, those kind of laptops would be used in an industrial environment if you're in a mine or something like that. Or they might be used in a military environment, which is also sort of dangerous and dirty. So here's our important point. Everybody who studies computing should know these things. Should know sequence, should know iteration, and should know selection. So sequence, very important, just means that when you write down steps one after the other, that's how it works. We start working with the first one and we keep going until the next one, right? That's sequence. We go in the order that they are represented. Iteration means that we can repeat things. So we've got a loop. Iteration, we call it a loop. So it could be a do-while loop or repeat until or whatever. Selection is where, and as it says here, I think it uses the term Boolean. Selection is where we decide. So depending on the inputs will depend which path in the program the processing takes. So we have things like if, then, else. If this condition is true, do this. Else, do that. And the else is what would be happening if it was false. So that's why we call it Boolean, because Boolean is true, false, right? So if this condition is true, do all this stuff. But if it's not true, then we won't do all that stuff, but we'll do this other stuff, which is where it says else. Okay, so very nice. Makes computing possible. We also call that branching. Selection allows for branching in our programs, but you need to know these terms: sequence, iteration, selection. Absolutely, you need to know those. And so there's a little bit about it. Sequence. When you have a bunch of steps, you start at the first step and you go to the next step. Pretty easy, right? I mean, yeah, you don't start reading from the bottom of the page, right? You start at the top of the program and you work way down. So here's this nice little diagram is to show you that sequence is important. You want to move this ball up to the exit. Well, you've got choices that you can make. You can move it left, right, and up and down. Now, if you try and move up without first moving to the right, you're not going to go anywhere, right? You're just going to crash into the wall. So in order to get this to work, the sequence is important. You have to go right, then you have to go up and up, right? It must be in that order. If you try and go up and then right, that's not going to work. Does that make sense? So that's our sequence. Sequence is quite important. Mathematics, you would have heard of, do you remember when you're in high school, BODMAS? BODMAS or BEDMAS or something like that, right? Brackets, exponents, or orders of operation. Brackets, exponents, what's the next one? BOD is division and multiplications. Last is addition and subtraction. So if we just have a bunch of things together in a single sort of instruction, that's the order that we do them in. We always do the brackets first, right? So mathematics, the reason why I'm saying that to you is obviously the people in mathematics sort of thought, well, that's kind of important that we do things in the right order. Because if we don't do them in the right order, we get different results, maybe the result that we don't want. And you can see this here. So we got same things happening, but then in different order. So if we do it this way, if you add 2 to 3 and multiply by 5, that's 5 times 5, that's 25. On the other hand, if you take 2 and multiply by 5, that's going to be 10, and you add 3, it's going to be 13. Very different answers. We did the same steps, but we did them in a different order. Different order made a totally different result. So we can see that our sequence is very important. And as I said, you remember that from high school when you did the BODMAS? I mean, you spent a lot more time than I'm spending talking to you about that. I think that it was probably quite important to you that you got things in the right order. The last one there is this link to this video, which I have put. The video actually is here. That's that video. I'm not going to show you that video because, you know, but I am going to tell you to watch it. All right, so you can watch it now if you want, or you can watch it at home or whatever. But do please watch it. It's there. I tried to make it easy for you to find it. Oh, yeah, I mean, it's there. Just click on the big red start thing. Then you've got this other thing, and maybe you can do this. Maybe we can get you sorted out in class now to join my thing now. When I say my thing, if I go to code.org, I wonder if I can log in here. I hope if I can remember my login, right? Yeah. All right. So what's all that about? Please select your language. Yeah. All right. There's my language. I hope you like that. All right. So there's a sign in. Oh yeah, you can sign in with Google. That's good. So that's how I'm going to do it, because I can actually, I do remember my Google password. All right, so I've got this. Now, if I go to my dashboard, what you'll see in my dashboard is I've got a bunch of sections. Do you see that? All right, now there's 3 people in this class, and I don't know who they are, but I could find out pretty easily, I suppose, by just looking at that. There's 3 people in this class who have already signed into the, who've already created accounts on this. So that's great. Thank you for those 3 people. So that means it's possible, right? It means it is possible. This is our login information. You'll see that I've got other ones because I've got other sections. And so you don't want any of those. You want this one, right? The one with the NRW. That's your course. And then that way I can look at and see what you've been doing. So the course that you're doing is the Express course. If I click on that, and what? Okay, so I can see that that's actually Aisha, Hafsa, and Saida. That wasn't hard, was it? Aisha, Hafsa, and Saida. Wasn't hard, was it? So maybe you could help other people to sort of get on there. You'll see that there's more than 20 exercises. 28. Ooh. So there's a bit of work to do. That's now. I'm not going to download from code.org all of your work and check it, because I don't need to, because code.org checks your work. I mean, when this becomes filled in, it means you've completed that. So the marks that I'm going to give you for this assignment are just going to be based on which ones of those things did you do. All right. So now you have an assignment, which is to log into this. Now log into this and do what? Let's look at that assignment. So sorry. So that's week 4. Oh, sorry. Yeah, there it is. Assignment 2, right? So in assignment 2, what is it? I mean, I think it says there's specific ones that you have to do. So slow. Oh my God. What are you doing, man? Oh, there we go. All right. So blah, 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 blah. Forget this, because just by following that link that I gave you, that means you don't have to do this stuff, right? So don't worry about this. The only reason why I'm giving you this is to look at number 5, right? So I think I saved you some work by sending you that link, because you just click on that link and fill in the details. You can forget this document. That's another way of doing it, but you don't have to do that. But what you do have to do is these 3 things: Angry Birds, debugging the maze, and what's the other one? Collect treasure. All right, now the reason why I'm giving you that is because you'll notice that there's like 28 lessons. 28 lessons is going to take you a while to do it, right? I mean, you're not going to finish that today. It's going to take you a couple of weeks. So to finish today's assignment, you just have to do these 3. Find the Angry Birds, debugging a maze, and collecting treasure, which I'm not sure how many of those lectures thing is. Maybe it's 4 or 5 or 10 or something. But yeah, that's what you have to do. Okay. So could you, before you leave now, could you all make sure that you have an account with that? And so Hafsa and Aisha and Saida will be able to show you how to do that if you want. And that's kind of what I want you to do today. Click on the link. Click on the link. Yes, the link is there. I'm sorry. I think it's there. So what you need to do again, because some people not sure, is I heard Hafsa say this, and it is correct. Go to the news, and you'll find that there's a link there, and you can just follow the link, and there will be instructions there. That's the easiest way to do it. Thanks, Aya. Anybody didn't sign? Sorry? Do you think you can finish it now? That's an assignment, right? Assignments due at the end of the week or something. Now, next lesson, we're gonna do the lab. So I want to give you enough time to do the lab, like a whole lesson to do the lab. I don't want to sort of say now, do the lab in 1 hour. You might be able to do the lab in 1 hour. I don't know. During the lab lesson, which is, when's that? When's our next class? Tomorrow? All right, yeah, that's when we'll do the lab. All right, so the assignment is like this. Please don't leave here without setting up thing. I'm not going to ask you to do the assignment now. You can do that when you're feeling a bit better after you've had a coffee and talk to your friends. I know you want to do that, right? Right, Shahid? What would it be like if I had coffee and friends? Just kidding. Just kidding. So yeah, but make sure that you have created an account so that you're ready to start. Now, I'll know that. As I said, I can go to my dashboard. That's how I know when you're done. So now I've got, oh, look at that. There's like 10 people did it. Mabruk. Mashallah. Oh, look at that. Who's this? 601. Somebody hacked the system. They did all of the exercises. Who's that? That's kind of weird. I don't know how they did that. I mean, seriously, that's like weird. Weird AF. I think maybe they're a repeat student or something. And yeah, isn't that cool? All right, so that's good. Wow. I didn't know that was possible. So we learn something every day, right? Either they're a returning student or they're a hacker.
No, I think repeating.
Yeah. Okay, students, I'm happy to let you go once you've created your account and you kind of know what to do, right? I know that. So okay. Thanks, Shahid. Bye-bye. Did you sign in, Shahid? Okay, I'm kind of tired now. I'm going to sit here and rest. Is that all right? You guys do what you like. Abdurrahman. What that means, good. That means you approve. Yeah, okay. Thanks, Hanan. Thanks. Asma? Asma, Saida, thank you. Fatma, how are you?
I'm fine. I took this course before, so it is already done. What I should do?
What do you want to do?
I don't, so I don't do anything.
It's only one assignment, right? Well, you'll learn how to do, instead of doing that, you can write Python programs. How about that? I'll give you some stuff. Don't worry about it.
So
We'll sort you out. I mean, you know how to do it, right?
yeah,
Because you already did it.
yeah.
Mabruk, mashallah. Are you sure you're not a hacker?
What?
Are you sure you didn't hack it?
No, no.
Farida, see you later. The code? Yeah, good question. All right. So, doesn't show on this page, does it? It shows here. Here's the code. Suleiman, it's NRW PGP. That's the code. All right, thanks, Maha. Have a nice day. See you, Aisha. See you, Hafsa. See you, Zabia.
What is the assignment due?
End of week. Like that.
This week?
Yeah,
On Saturday?
yeah, something like that. Is that all right?
Because there are a lot of videos, so need to watch them.
Is this nice stuff?
I think so.
No, no, it's not.
You're not going to make it a tattoo, are you? But this is like
It looks like a tattoo, right?
a decal for your car, right?
Yeah, I just leave it to your imagination because I have no idea what's this.
So, I mean, I don't see many Arabic or Muslim people with tattoos. Maybe it's haram.
Yeah, it is.
Okay, that's good. I don't like tattoos either.
Really?
You see it on me? No tattoos. Why I'm going to put something on my skin? It's my skin, right?
Yeah.
If I want to paint something, I'll put it on a page. Sorry. All right. Yeah. Oh, yeah. That's good. So you need to join my So I don't know how to do that, but you need to, you have an account. Are you in the, did you join the class? So you can still follow this link and join the class, I think. And if you've already got the account, that's great.
I went to the link and then it said you already have account.
That's fine.
Logged in.
I-
I don't know, like the one I did last semester. If you already done.
All right, so yeah. Let's have a look. Are you one of these? Iman's already finished also. Is that you? All right, so can you, when it says that you've already done it, just try and join anyways? I mean, or else talk to Iman. How did he do it? Iman, can you, it's Khalid? Can you show Khalid how to join even though you've already completed? Because he's like you, he already completed, but he wants to join. Khalid wants to join the class, but he's already done it.
حتى انا طلعت نفس الشيء ما ادري اذا اعدل افضل ولا لا حتى انا نفس الشيء الكورس اللي طاف الخط.
I think what you just need, do you still follow that link just the same as everybody else? Follow this link?
Repeat it, by the way.
Huh?
You can't repeat it.
Yeah, but you need to join this class, right? So you joined this class. Did you follow this link?
Yes.
All right, so you can, yeah, so maybe you didn't finish. So when it said that you've already finished, did you quit? Maybe you should. So what did you do when it?
I didn't finish it all. Just there is 5 or 6
Yeah,
lessons left.
but what did you do when it said you've already joined? You still joined, right?
Yeah, I still joined from the last course and joined the new one this course.
How did you join the new one?
Clicking by the link.
Just
click
okay.
the link.
Yeah.
I would add it with the home course. Me? So join.
Abdurrahman is joined.
Yeah.
Okay, join.
Awesome. So I should be able to see you here. Let's see. Thank you. That's all I wanted. And you know, you don't have to do this stuff again. You can if you want. Khalid, there you are. So you need to finish those ones that you didn't do. Okay. No problem. Sorry. Do I have who? If he's there. Abdurrahman, yeah, he's here at the top.
So which one is this?
So it's the Angry Birds. It's on the board. Okay, thank you, Sulaiman. You too. Yeah, Angry Birds. Yeah, it's kind of like debugging. Yeah, I think you've probably done it. Or, yeah, Angry Birds, you've done it. So yeah, do it. So the first 3. Yeah, you've done it. Yeah. You want to do it again? It's up to you. Okay. All right, no problem. So yeah, that's a good question. So let's go to D12. So I put it here. I made a video of it. Yeah, if you go to the home and the visit, after the attendance down here, this is what we did yesterday. See, Sunday the 30th. Made a video on our lecture, but it was this. And I asked people to look at this lecture. That's it. And so today also I'm asking you to look at that video and look at this lecture. I will put the video, am I still in a, yeah, I still am, right? Oh gosh, that's not great. Long video.